Hello everyone, as I told you that we will do one activity of class 9th. Fine. Today we will do midpoint theorem. Today we will understand how to verify midpoint theorem. This is a part of class 9th quadrilateral chapter. Now see, first of all, the objective, as you can see here, it is to verify midpoint theorem. And what material is required? A piece of cardboard, color paper, geometry box and a marker pen. Now see theory. What theory says? The line segment joining the midpoint of any two sides of a triangle is parallel to the third side. This is a fact, and it happens whenever you will join midpoint of any two sides of a triangle. That line will be parallel to the third side. It means, if I'll show you something like this, this is a triangle and these are the midpoint of this line and this line. If I say this triangle ABC, if you join, say, this D and E, suppose, if I join it, then this line will be parallel to this. Today we will verify this also. Now we will see the procedure to find the midpoints. First of all, you can see here what is written here. Paste one sheet of white or colored paper on the cardboard. Before doing this, take a triangle ABC and by paper folding method find the midpoint of it. How can you do this? Just join the end point of it like this and join it. You can see here that length is same from this side and from this side. So this point, this fold, you can see, and similar thing you will do this another side in any two side of triangle. You can see again a crease is there. This crease, this part, this is the midpoint. You'll mark it. These 2 points. These 2 points are the midpoints. If you say this A, B and C, and these points, these midpoints are D and E. Just join these 2 points carefully. This line DE will be parallel to this line. We'll further solve it why it will be parallel. Okay, this thing I have done already with this triangle. You can see D and E are the midpoints. Now cut another triangle CEF from another sheet so that this ADE is parallel, congruent to ADE. CEF triangle you have to make, which should be congruent to ADE. So how can you do this? Just take a piece of paper and according to these sides you can make a triangle like I have done it here. You can see these two triangle ADE and this orange triangle is CEF. Now I can, if I'll make arrangement like this, see CEF. Now we must paste it. Now paste it in this way. In CE side is common in both the triangle, this ABC, this EC side is common, so you can paste this triangle in such a way that CE common side is coming this side. Now this is the procedure part. Now see observation. First observation, there are so many observations part is there. See what will happen. As you know that CEF is congruent to ADE, so DE will be equal to EF. See, DE will be equal to EF because this part is equal to this. I put it like this only. And now measure DE. चलिए measure करते हैं DE को. DE measurement 2.7 centimeter. BC 5.4 centimeter. Now you will find that DE is half of BC. 5.4 half is 2.7. So we have verified this. This is the midpoint theorem. Says, and DF is equal to BC. DF is equal to BC, as you can see here. This is 5.4 and similarly BC was already 5.4. This is 2.7, 2.7, 5.4 and this total is also 5.4 centimeter. Okay, now the second observation, as you know that is this triangle CEF is congruent to ADE, so AD equal to FC. AD equal to FC. And this D is midpoint of AB. It means these two lines are equal. And this is equal to this. So I am writing it here. AD is equal to BD and AD is equal to CF. AD equal to CF because triangle CEF is congruent to triangle ADE. Since D is midpoint of AB, AD is DB, as I have shown you here. AD is equal to DB. So we got FC or CF is equal to BD. Now you can observe easily that DF is equal to BC and BD is equal to CF. So DFBC is a parallelogram. So this is actually the midpoint theorem verified. Here, because of this that DFCB is a parallelogram, you can say that BC is parallel to DE. DE or DF, that is the same thing, because in parallel thing we only see the direction of lines, which is same in DE and DF both. So what midpoint theorem says, I am writing the final result. Here you can see in this diagram DE is parallel to BC and DE is half of BC. This is the thing which you must remember and which we have verified through activity. Thank you very much, and you can write it. I'm just showing you once again. You have to write this in your activity copy to verify my midpoint theorem. Material required, theory part is this one which I explained you here. Now procedure we have discussed. Find midpoint theorem midpoints by paper folding method. Okay, now cut another CEF triangle. That is another activity which you have to make another CEF triangle from other colored sheet, as I have shown you here. This triangle and this must be congruent to this. And now how you will make these two congruent, that you have to think. Now observation part, there are so many observations which we have already discussed. You just have to write these all things. This measurement will be different in your part because you will make different length triangle. So we will see how many of you are getting correct observation. And this CEF triangle here, you are proving that DFCB, this DFCB is a parallelogram which you have to prove. And now finally this is the result which you have to verify. Thank you, students.